thought you did. Okay? So let's look at this rather complicated mess. All right, this here is a wing. That's a cross-section of a wing. See that? Here's molecule A of air, molecule B of air. Okay? The wing is going to go this way, correct? So this molecule A, guys, is going to end up over here, right? Same molecule. So if it's going to go through the air, this molecule is going to go this way, correct? It's the blue. It's going to go this way, and molecule B is going to go this way. Do you see that the time it takes for molecule A to go from here and molecule B to go from here to here is the same? See that? You get it? That's important. Do you see the distance A travels is larger than the distance B travels? Do you see that? So, larger distance A divided by T is going to be VA. Smaller distance B divided by T, those are T's are equal, is going to be VB, correct? So VA is greater than VB. Distance A is greater than distance B. That's greater than this. TA is equal to TB. Therefore, VA, as I said, is greater than VB. So the pressure here, this pressure is going to be greater for pressure B. You see that? Pressure B is going to be greater than pressure A, and that's called lift. As the velocity of a fluid increases, the perpendicular pressures decrease. Correct? So if I have a piece of paper and I increase the velocity, I get lift. You get that? So the pressure is less on the top. Therefore, on a windy day, atmospheric pressure is less. On a windy day, it's less. It is. On a windy day, the downward pressure is less. If the wind's blowing right at you, Mohammed, the pressure on you is less. Right? Yes? In a hurricane, why does the wind blow roofs off of houses? Because the wind on top of the roof reduces the pressure. On the bottom of the roof, inside the house, there's no wind, right? So the pressure is still high. Low pressure on top of the roof, high pressure underneath the roof blows off. You get it? Now, so remember, let's see how many of you, the 5 of you, Zaytun, Abdul, Mohamedou, Axel, Sadia, how many of you are going to remember that Bernoulli's principle is really from the conservation of energy?
I remember.
Okay? Now, so this is a stream, a brook, a lake, a river. And as the river narrows, the velocity is going to become greater, isn't it?
Yes?
Yes? Thereby, the perpendicular pressures are going to become less. So the bubbles can expand. Correct? You get that? It's real important. Yes? So as the velocity increases, the perpendicular forces or pressures will decrease. Yeah? This is something that's on your test. And the reason I leave it there is because you should know what a cathode ray tube is. A cathode ray tube is simply a tube or some kind of, let's just keep it simple, sealed glass vessel where all the air is sucked out. So the pressure is greater on the outside than on the inside, because on the inside is a vacuum. Years ago, when I was a kid, all the television sets were made of giant cathode ray tubes. They were enormous. Have you ever seen one? An old television set, they were enormous. They weighed a ton. And it was a vacuum. So what would happen if there's a vacuum inside the vessel? Is it going to explode or implode? Here I have a cathode ray tube. It's a solid glass sphere. No, it's a vacuum inside. So is that going to explode or implode? What is it? What is it? Implode. That's right. That will implode. The pressure is higher here. Pressure 1 is much greater than pressure 2. This is like almost nothing because it's a vacuum. Yes? It's almost nothing. So it will implode. Okay, now. One more thing. Two more things. If I have a helium balloon on the moon, is it going to float away if I let go, or is it going to sink? Is it going to go up if I have a helium balloon and I'm on the moon? Is it going to rise or fall if I let go? What's going to happen? What? Remember, a helium balloon no? Is it going to rise or is it going to fall? What makes something rise? It has a greater buoyant force, right? Correct? Yes?
Yes.
So like a block of wood, large volume, correct? It's going to displace a lot of air, right? A lot of water, correct?
Yes.
Is there any air on the moon? No. So is it going to have any buoyant force? Is it? So it's going to fall like a rock. So the helium balloon will fall. Now here's something that Zaytun was asking about, and I kind of ignored it, but it's important when it comes to fluids. Here I have a candle. Okay. Here I have, okay. Let me turn these down. I'll turn them off. So, let's say I'm going to do this. I'm going to make a left-hand turn.
Oh my God.
What happens to the flame? What does the flame do? What does the flame do? You ready? What happens? What happens? Can you see it? Can you see it out here?
Yes.
You ready? What's happening?
Points towards the direction that you're going.
It goes in the direction of the turn, doesn't it?
Yes.
Okay? So if I have the car windows closed, and I have a helium balloon, and I make a left-hand turn, which way is the balloon going to go?
It's going to go to the left.
To the left. You get it?
Yes.
Sure?
Yeah.
Yes? Same. Okay? I think that's it. Did we finish? Oh, one more thing. If I have a helium balloon on Earth and I let it go,
It shall rise.
Until when?
Until it
Until it
reaches.
gets out of the atmosphere.
No, until when?
Atmosphere, but.
Until when?
Until.
Until it explodes.
Until something pops it, yes.
Till when?
When you let go of a helium balloon, it's gonna rise until
I'm not gonna tell you, you're gonna think about it.
until the ozone layer.
Well, when is it, how far is it going to rise, a helium balloon?
It's gonna go until the ozone layer.
Think about the moon. Think about the moon. Think of a helium balloon on the moon,
Because you said like on the moon.
Sinking
there's
or
no
rising,
air, so it's gonna
and
sink.
then the helium balloon on Earth, we know that if you let it go, it'll rise, right?
Yes.
Until when?
Until there's no more air.
It'll stop when there's no more air.
Yeah.
Yeah.
Remember, guys, listen carefully. Listen. Archimedes' principle says that
Concentration.
the buoyant force is equal to the weight of the fluid displaced. A soccer ball is going to have more buoyant force than its weight. Correct? Because why? Because it's going to displace a lot of water. And that water that it displaces is heavier than the ball in the gas. Correct? Is heavier than the ball in the gas. So it's going to rise.
Yeah.
Correct? What about the moon and the earth and letting the helium balloon go? What's going to happen? We're done.